Hello, welcome back to Live Noding. In this episode, I'll be doing improvisation Blender noding using spectrum nodes, and you'll generate something like this. So it's pretty easy and simple. So let's just get started. So if you think about the elements of what you see just now, it's basically you can make something like that using cylinder and adaptive polygons, right? You just need to work on the cylinder and try to randomize the cylinder. So let's do that very quickly. So by default, cylinder will make a cylinder. You can adjust the radius of the top and the radius of the bottom. On top of that, you can always randomize the parallel or the meridians. So that's the key here. And let's say we are using something like vector noise. So let's say for vector noise, we can have scalar output, and you can quickly just use a line and plug the line into the vertices, and as the output, you're gonna have vector noise. And this number can goes into the parallel, and you have something like that very quickly. So this can be like a stupa, or can be like this can be a UFO, whichever you want it to be. And you have a lot of control already. Let's save this very quickly. So let's save this as adaptive mushroom. And with this, you can simply plug this into adaptive polygons, and you can use icosphere. Okay, let's connect the edges. So all we need to do is to plug this donor. You can have multiple donors and variations. I'm not gonna do that. You can try yourself. Okay, so this is the result. So based on this icosphere, it's generating, and it's actually pulling out the cylinder. Maybe I need to expand this a little bit. But you got the idea. This one is actually okay. We have control over the width coefficient. So we can try controlling this using the radius. So once again, we have this Katamari mushroom ball. I think this is quite neat. And you can randomize the noise. You can have unlimited variations. You can always actually output the actual icosphere. So this is what was happening. The adaptive is trying to fit this object into the frame. You can randomize the Z, and you can offset it. You can rotate it. If you want to have more control, you can also use curve mapping. So we have curve mapper in Spectral, and we can use range number. So let's say for the range number that we specify here, make a value between 0 and 1, and then map it with curve, and then plug this into the meridian. So now this curve will control the shape of our object, supposedly. Let's see if I wonder if I made a mistake. Okay, so the shape is being created, but maybe it's being pulled too much, so we don't have that shape anymore, and it's kind of flipped. Okay, interesting. So yeah, this is how you can reshape the objects. I think you can flip it this way. Oh no, no. So I'm trying to remap the value using this. Maybe it's better to just use vector noise. Keeping it simple. Back to the original design. Now it's just a matter of fine-tuning this. Currently it's looking like a bottle. You can animate the growth like that. Let's see what else we can do here. File save as. You can randomize the seed, maybe to have each one slightly different. You can rotate, or you can use dual mesh between the icosphere and adaptive polygon. Okay. Yeah, this shape is always interesting. Icosphere is always well known for this kind of thing. So now it's just a matter of playing around with the noise. Hopefully you find the one you like. So Z coefficient. So Z coefficient can be randomized. So that's the property of this adaptive polygons. In the end, you can always join everything, merge into a single object, and then remesh it, and you have these objects that you can print out. So random number again, random number float goes into the Z coefficient. You can now randomize the length. Because it's pretty neat. Oh, you can see how it's behaving, which is interesting. You can set it to $1 per face, so I think that with $1 per face it will try to randomize based on the Z of the face. If I Okay, actually this is interesting. With the icosphere and dual mesh, it's actually doing subdivisions, and so that we have a polygon face, and then as a result we have it working only on the face of the icosphere dual mesh. Yeah, that's interesting. Even I didn't know that. Okay, anyway, with this, you can always remesh, making sure everything is close. So remesh is always super handy for a lot of things. topology wise, maybe it's not the best. However, this guy is printable. All right, so there you go. That's another improvisation using, the usual suspect: icosphere, cylinder, and adaptive polygons. Thanks again for tuning in, and I'll see you next time. Thank you. Bye.